I'm Hamel Husain. I'm going to be the host for today. I'm an entrepreneur in residence at Fast AI. And with me, I have two of my esteemed colleagues in machine learning. Emmanuel, he's currently an independent consultant, and he was previously a staff ML engineer at Stripe. And he actually worked on some very interesting things at Stripe, like fraud models, which a lot of people end up using because a lot of people use Stripe. So that's really interesting. And he was also head of AI at Insight Data Science. And that's also a big deal to me because a lot of the colleagues that I had when I first started in data science were from Insight. Also, you may know Emmanuel from his book, Machine Learning Powered Applications from O'Reilly. It's one of the first ML ops type books that I remember reading or seeing out there. And it's a really good book. I highly recommend checking it out. It's kind of like technology agnostic and kind of walks through a very end-to-end way of thinking about operationalizing machine learning, which is really good. Also with us, we have Shreya Shankar. She is currently a computer scientist living in San Francisco. She is doing a PhD in databases at UC Berkeley. And she was, prior to this, she was the first ML engineer at Viaduct and also did research at Google Brain and also software engineering at Facebook. One thing that's really interesting about Shreya is her research it touches applied machine learning in a ways that you don't think academics usually do, but she's actually very ingrained into what practitioners are doing in applied machine learning. She focuses on that, and recently she published a paper surveying the field of applied machine learning and its pain points, and that's been discussed. She's given some talks on that, and she was recently interviewed by Lucas Biewald, the CEO of Weights and Biases, about that paper. So when I first heard of like LLM ops, I wanted to poke my eyes out because I thought, oh, it's just like another. When I first saw the word, I said, okay, this seems like some kind of hype word or something. Emmanuel, I know you do some consulting around LLMs. You do a lot of consulting around LLMs. I know, Shreya, you also have been looking into LLM APIs. So my question for both of y'all is, can you share any ops stuff you think around LLMs that have been useful so far, or if there is something useful? And like also, what is your sense of the kinds of inference systems that might be useful here, or if you have looked at that at all?
Well, it's a big question. Okay, so I have one project that I'm working on in which I have two, I don't know what to call them, clients, customers sounds really fancy, but like I'm not a startup, I'm a researcher. The two case studies that I'm working with that are using LLMs. And the target audience that I'm interested in is people who know how to program, but they're not data experts and they're not like ML experts. So they can write Python, but they don't know how to reason between training and serving pipelines. And they don't know what to think about like updating data, what state is updating, how do I choose the API, blah, blah, all sorts of things. But they can make HTTP requests. They can write Python, they can deploy Python. So just to give you a sense of that. So when it comes to LLM ops, I think the first big challenge that I'm seeing that like stuff like LangChain is kind of solving is state management. I first deploy kind of my pipeline as a developer, and I learn new information that I want to inject into the prompt or keep in the prompt, or I want to fine tune on, or I want to, summarize, make some action. And this state can be different per end user. So I guess one big challenge around there is like, how do I do that state management as I iteratively question my LLM API? And there's like a lot of research these days in kind of chain of thought prompting or all these fancy terminology that is just, how do I reason about state management to finagle my way to the best user experience? So that's one. And I think the other one that I'm seeing design pattern that people are struggling with is how do I incorporate information about the world that the model might not have been trained on. So one example of this is like retrieval, or like I have custom documentation that I want to make a chatbot on. So solutions like LangChain might summarize each document, put it in a vector, and then do some sort of like nearest neighbor, vector similarity search, and so forth. But every time I call the summarization or call the LLM inference API, right, I'm paying money. There's a lot of, I don't know, open questions about like what are the best ways to solve these problems.
Okay, when I'm using like things like LangChain, there's a nagging feeling, and maybe just I'm just like a crusty developer or something stage of my life. Almost have this feeling that okay, it's doing something somewhat simple, not too simple, but it feels a lot of complexity for what it's doing, at least for a lot of things. And like, where does it fall for you in terms of, trade-offs?
It feels complex because it is so hard to make an abstraction that solves everybody's LLM use case. But all LLM pipelines are like the model with a bunch of guardrails around it, bunch of rules, bunch of filters, whatever it is. And all of these rules and guardrails are different for each application. That is like it's really frustrating, I think, from the tool builder perspective. How do I build like an abstraction that's like simple and solves more than one case? But I feel you on the like, yeah, it's like so complicated. Why are there like 10 different contexts? Why do I have like a different integration with each LLM provider, with each vector search vector embedding database? It's like, I'm with you on the frustration here.
I think part of it too comes from like, if, back when I was at Stripe and in a lot of ML companies, you have these you manage to cast your business problem in a very well-defined mathematical way. Like eventually you manage to cast, like fraud prevention at Stripe to like, okay, we have a binary outcome, 0 or 1. We have other numbers. We use the numbers to predict the final number. It's like a very well framed situation that you end up in the end. And so you can build a bunch of tooling around it because you're like, okay, well, I can make a lot of assumptions, right? I can make the assumption that, you have two classes you care about. You're going to care about the distribution of these classes in various domains. You want to slice and dice the data, et cetera, et cetera. Whereas like, it feels like the output space and input space of LLMs is just like all of language. And so you have this massive beast that can kind of like input or output anything. You can't really make assumptions. Like even I've worked with folks that try to use them as something that's closer to classifiers, but because they output natural text, sometimes your LLM that you're using as a classifier is just going to output like another token that you didn't expect. So your tooling has to kind of like handle just a really like a huge variety, I feel, of edge cases. And so it makes it hard to build like nice, clean abstractions. They have to be these kind of like messy hairballs.
Emmanuel, can you tell us a little bit about your work on LOM Consulting? Like, what kind of stuff do you do? Like, what does it usually involve? I mean, yeah. I have a feeling like it's different than like traditional ML projects that we have seen in the past. So that's why I think it's interesting.
Yeah. So maybe for context, what I worked on most recently before doing this was like very traditional ML stuff, as you point out. So like making new models, making ML models better, or working on, I spent a year kind of leading a large ML ops effort, but again, for kind of traditional ML, so making model releases easier, safer, that sort of stuff. And now recently working with LLMs, initially I did a bit of work with just prompt engineering, which is not machine learning. It's just, I don't know, insanity in my opinion, but that's just the world we live in. So doing some of that, and then basically comparing various APIs to various open source models. I actually think there's like an interesting topic there for ops, which is like, you have all these open source models and even just running them is a pain, much less serving them, fine tuning them. And so that's been the other side of the work, kind of like getting these models to run, getting these models to like be fine tuned and have good results for tasks. What often happens is a company will start with a API and it'll work for a while. And then at some point, maybe they'll want to expand outside of that API, or like they have some, exactly what Shreya was saying, they have some internal data that they want to leverage, and they try doing the kind of like embedding vector store, and maybe they found that it didn't work that well, so they want to fine tune their own model. So that's the sort of work, kind of comparing that approach and its costs and its trade-offs to, having a prompt engineer just do prompt engineering for two more weeks. I think the last thing I'll say about it, which I think is really fascinating in the field and a lot of my work, is like, it's hard right now to know what will give you the best bang for your buck. So it's hard to know whether you should like spend 10 more hours prompt engineering, or whether like you've reached the limit of the model and you should just get another model or frame your problem differently. And I think that that's maybe like one of the challenges too with building nice abstractions, is that people don't really know what the next best step is.
It's interesting. Sounds familiar almost from traditional machine learning in some ways.
Yeah.
Okay, I want to switch gears. I want to definitely come back to LLMs. I think we could spend the entire talk talking about LLMs. This is how interesting they are and like how they shift. There's like a different modality of work and all kinds of stuff. I don't get too hung up on that. So in Shreya, in the recent paper that we're discussing on operationalizing machine learning, you qualified the participants as, by if they are carrying a pager, if they're going to get paged, if something goes wrong with the model. That was like a criteria for, okay, are they doing applied ML? And I thought that was super interesting. And the reason that is like, from my experience, I observed like, I've only seen pager duty kind of assigned to machine learning engineers maybe a third of the time. I would like to see it done more often. But one kind of interesting sort of detail is I've seen that like the monitoring systems that the rest of the organization uses, like, I don't know, Datadog, Prometheus, whatever, for web apps, like the ML folks have a hard time pushing their metrics and things and instrumenting them there. And then what ends up happening is like it just kind of gets left out, sort of. And then some other more loose thing is there, like a dashboard or something. It's not really carrying a pager. So I'm just curious, like, again, this could be just because like I'm just doing a lot of associated with a lot of maybe uncool stuff. But like, how does it work? Like, how does it? Do you see people getting trapped in that, or like, how did they kind of fit in with, like, let's say the rest of, monitoring or,
Yeah. Okay, I think that's a great question on like, why can't people use Datadog? So let's be clear, SREs get a ton of alerts also, but they have the ability to look at an alert and tell you whether it's meaningful or not. Even the most expert ML engineer is looking at an ML alert and just cannot tell you whether this feature drifted by this much. Is this meaningful or not? No one knows. So that is like the difference, I think. It's not necessarily the tooling, it's just the fact that semantically we don't understand what actually causes the ML pipeline to be broken enough to warrant some engineer's attention. So that's one thing. I think another thing is ML engineers might not be carrying a pager, but they will get Slack notifications or CloudWatch notifications that were always in the form of this column, which is feature or output prediction or whatever, has this deviation from this threshold, like X deviation from Y threshold. And this is just a pain. You're going to get hundreds of these things. In my recent data validation paper, which I promise I hopefully will put online before before this panel goes live. But we identified several causes of false positive alerts. One is highly correlated features. Data scientists love making highly correlated features, like probability of click after 1 second, probability of click after 3 seconds, after 5 seconds. These are by definition correlated, but they all exist because they make the model have higher performance. So in this case, like, how do you handle very correlated features? A lot of people, as Emmanuel said, like to monitor all the features as well as the predictions. If I were to tell somebody, if you had to just monitor your prediction, like plot histograms of your prediction column. That's it. Sliding window histogram of what you predict. You will identify whatever anomaly you identify there is worth your attention. Like you won't catch all the problems, but whatever you catch, you'll catch like a real issue. Which means like the feature problem is very hard to do. Another big thing is we identify in the paper is that people love to compare the current partition to an aggregation of all historical partitions, which does not make a lot of sense. Like, suppose today is a holiday. I only want to compare it against previous holidays. Suppose it's the weekend. I only want to compare it against previous weekends. I'm going to get false positive alerts if I compare Saturday to Friday for a lot of like e-commerce. So it's going to happen. So like being smarter kind of like how do we alert just like bare minimum and not just throw alerts at everything and submit this huge PR with all of these things that we're alerting. I think that can go a really long way.
Yeah, that gave me PTSD for experience getting paid.
Tell us more. Yeah, that's PTSD is really interesting because I think it like probably highlights what a lot of people feel. It gave me PTSD. It gives me PTSD too, which is why I like to talk about it. It's like a therapy.
Yeah, no, I think I think everything you said was exactly on the money. Both the kind of like, it's actually super hard to craft these alerts. Like everything you said makes sense, and yet is not the first thing that I think anyone thinks of when they're crafting the alert. Like, we'll just look at like whatever the running mean, and if it's, like outside of a certain bound, we'll do something, or even if you do a more complex statistical measure, you forget that like, yeah, you're going to get paged every Sunday or something because like the traffic changes. And so I feel like you learn this because you get paged Sunday and then you actually do the right thing. The other thing is that, I think to Hamel's point, a lot of these tools make that debugging hard. Like, I feel like I'm decent at ML, and I can't tell you how many times I've gotten paged. I look at the chart and I'm like, oh yeah, something is going horribly wrong. And then I zoom out, I was just looking in the last 5 minutes or something. I zoom out like 24 hours or a week, and I'm like, oh no, this is like normal traffic patterns, just at like where, in like the ebb and flow of our traffic or something of the kind. And I think a lot of tools aren't really built for that, or they don't really show you that well. Like a lot of like histograms are just like by default the most recent n minutes without contextualizing it. I don't know if like there's easy ways, or if there's opportunities to like build specific tools rather that do this, or if it's just, to your point, using them better and kind of thinking carefully about.
Were you forced to use like the traditional, like to also Shreya's point, like I have been forced or attempted, people have attempted to force me to use those traditional Datadog, Prometheus stuff to jam in my ML stuff in there. And which is why I have PTSD. Is that common? Like, have you been forced to jam your stuff in there too?
I'll maybe frame what you're saying in a different way, which is I think there's usually a unified stack, and it's just like that's the solution used for logging, for log searching, for log aggregation, for like whatever. And so like but I also don't know. Maybe I don't know the field well enough, but I don't know if there's like a cool ML solution that does this for you, like that you could use to replace some of these, that does like the ML part really well.
I don't know. Yeah, I don't know either.
Yeah.
That's a good question. We should find out. I would like to know.
Nothing I've seen. I don't know. Yeah, I've tried to use like, I once went on this journey of like, I'm going to prove to everyone that you can use Prometheus to monitor anything ML related. And like, yeah, I could, but it was just like shoehorning. I just felt like I was trying to like shove like what is the analogy? Like a square peg in the round hole. Like I like whittled it down and I made it work somehow. But I was doing all these like high cardinality joins over Prometheus QL, like with things that are just like you shouldn't be doing. And in the past, I think I was more software or engineer oriented. Like you should be able to do any problem with a software engineering tool. Like ML ops should be subsumed in DevOps, or LLM ops should be subsumed and like consumed in ML ops. But I feel like, these things these are new design patterns, new things we're learning. They do warrant different tools. It's okay.
The other thing I'll add in terms of tooling, because I was thinking how many were mentioning that like ML engineers should, maybe carry pagers more often. I feel like I used to agree with that sentiment a lot, and I still do to a certain extent. But one thing that's clear to me is that the resolution of issues is just so different for ML that you kind of want different tools, right? Where it's like, if you see, engineers or SREs, like there'll be a lot of like, oh, what does this bit of code do? Let's make like a quick PR that fixes it, or roll back this change, Whereas for ML, at least in my experience, like 99% of the time, it's retrain the model, Shreya's point, or circuit break the model, like until we can get up and actually like investigate and just like, don't run the model if that's something that you can do at all, which feels like you're not really providing any of the value from being like an ML expert if you're doing that. Like it's just like you could almost just automate it, right? Like don't even page anyone, just do that automatically. And so I don't know. I feel like there is a room for like either it's tools or just a better model of like organizing ML software so that you can actually do these like quick hot fixes. But I just think like as a field, we're not really there yet. We just have very blunt instruments.
Both of you mentioned kind of DevOps, and like Shreya, you mentioned, okay, you went on this quest for Prometheus and like software engineer mindset. One question that always comes up around that when we talk about this like ML ops term is like people like talk about DevOps and how like it's inspired by DevOps or whatever. And then like there's a central kind of a set of tools in DevOps, like the CICD tools. And so people always ask me, like, is there what is CICD for ML? And I don't really, people always ask me that. The answer is very complex. It's not just, okay, GitHub Actions on your ML. Doesn't make sense. So like, how do y'all think about this CI/CD for ML? Like, is there something there to like carry over in some ways? And like, by the way, I'm teaching a course on this, like CI/CD for ML, the teaser. But I don't have all the answers either. So I'm just curious, like, what your kind of take on the CI/CD
So when we
is.
started the interview study paper, we named the project CICD in machine learning because our goal was to go talk to a bunch of people about their CI/CD practices. But really quickly in the first 3 interviews, we didn't include that in the study. But we did 3 interviews and we realized that already by saying CICD, we biased them so hard that there was like no point of recovery in the interview. So that's why we dropped the CICD. The first big learning I had was that everybody is in their different stage in their ML journey, but they all may say that they do production ML. Some people will say they do production ML and their job is to generate dashboards for their CEO. Some people will say they do production ML and they work on Instagram recommendations. So like, at least for the interview study paper, we wanted to hear more about the latter and not the former, even though they're both kind of valid production ML. So there's that. We found that it was easier to think about CI/CD when we were like talking to people who worked on specific applications. So for example, in autonomous vehicles, we talked to people from 2 or 3 different autonomous vehicle companies. And they have like very robust CI/CD practices around like data unit tests that they must pass before they deploy any new model. Like they must be passing, like be able to classify this pedestrian at this intersection or like this visibility or this lack of visibility or whatever. So they've got this like curated set of like adversarial examples, but they're consistently making sure passes. But their task, their domain needs that. So their CI/CD includes this as well as a validation set, as well as code review, whatever. There are other forms of CI/CD, like retail analytics companies, where they talked a lot about when they have many pushes to the model. So in AV companies, you don't have that many new models or new pushes to the model. But when you have many pushes to the model, it's very easy to get diverging evaluation sets or evaluation notebooks. Like if somebody forks an evaluation notebook and makes a little bit of modification to that and is using that to now deploy all the new versions, now you've got this like mess, right, to try to reconcile. So how do we make sure that every evaluation and deployment process is the exact same for every engineer at the company? I don't know if this answers your question, but it really felt like depending on the patterns and like the stakes of deployment, CI/CD just meant a different thing to everybody in a way that I have not seen in software.
Yeah, my experience with the word CI/CD is people don't know what the term means even. Like it's kind of like the word Coke for soda. It's like, it's like just a kind of a sort of, like it's like Circle CI or GitHub Actions, like that's CICD. But like, what is, a lot of people don't even know what CICD stand, like the acronym even means. And like, it gets really confusing really fast. Daniel, do you want to continue your thought on CICD?
Yeah, I mean, really quickly, I think I basically agree with everything Shreya said. I think there's maybe like two takeaways that are like really, really quick and valuable, which is one, automating as much of it as possible, because I think a lot of like ML pipelines die by exactly the example that you mentioned, which is I use a different eval set than yours, and so I ship a model that actually sucks. Or the way that we deploy model is a bunch of manual things, and if you deploy it slightly differently, something will break. So automating everything, and then like thinking of model performance as kind of like successive checks. So you mentioned these specific examples, which I've heard called like golden sets sometimes, of like, data that your model must perform well on. Ahead of that, you can have a check, which is, does this model perform better than the old model? If it does, go to the next check. And then after that, usually having something like shadow mode, where you can like observe your model in the production environment without it actually doing anything. And you can verify that it's, for example, its distribution is not too far in terms of KL divergence, let's say, from the prior model or something. And so you have this like assembly line of checks. And if at any point, it kind of like fails one of those, then you have an engineer look at it, or you roll it back or something, is something that I think is like a reasonable approach to CI/CD for ML. And then like each of the steps will probably be super different for each company, as Shreya was saying, but at least like having that approach is pretty generalizable, I think.
Okay, so it looks like we're coming up on time, but we didn't get to talk about some things that I kind of want to mention real quick. So Shreya has an upcoming paper called Moving Fast with Broken Data, which is like basically encapsulates all of data science, in my opinion, because that's what
wow, that's generous.
That's what it feels like. So Shreya, do you want to say something quickly about that? Like that paper, what people should look out for?
Yeah. How do we automatically validate and monitor data without users specifying, bounds and the metrics that they care about and everything, and making sure they're up to date as data changes? And how do we do this precisely with good recall of failures?
And there's a lot of things I wanted to get to in terms of, Emmanuel work on LLMs, things around like what, how to fine tune stuff effectively, and, like the accessibility to different models. Emmanuel, you do consulting as well around this. Where can people find you if they want to get in touch with you?
Yeah, I'd be happy to chat with anyone that's kind of trying to make LLMs work for a practical problem, or trying to kind of find their way through fine-tuning these models for useful tasks. So even if you just want to grab coffee and chat, I'm happy to talk about that stuff. I think it's fascinating. 2 ways to reach me. If Twitter still exists when you're listening to this, I'm at MLPowered on Twitter. And if not, mlpowered.com is my website, and there's like a email you can use to reach out there.
All right, great. And Shreya, where can people find you? What's the best way to sort of engage with you on your research or anything else?
Email me, Shreya, Shankar at berkeley.edu. And there's like a 50% chance that I reply right now. I'm really sorry. Hoping to increase this number.
That's not bad.
Maybe it's generous, maybe 30%, but I'm really trying, I promise.